Hi, it's Miss Molesbury here. I'm sorry I can't be with y'all today, but you have two goals without me there. Number one is going to be that we're going to review what we learned last class. And then number two, you're going to start the next lesson. And that way we'll kind of know which parts you might be confused about, and we'll review it again next week. So this first video is going to help you practice solving quadratics. So make sure you have some paper where we're just going to do a couple examples together to help you remember the three types of solving that we did last class. So number one, well, I guess what's our goal here? We're solving quadratic equations. And the first method is factoring, which of course we reviewed how to factor back in Unit 1. We said that for factoring, our equation must be in ax squared plus bx plus c equals 0 form. So our equation has to equal 0, and if it doesn't, we're going to make it equal 0 in our first step. So we're not going to do a lot of examples in this video. I just kind of treat this like your warm-up, like we would be doing at the beginning of class before you do some practice. So the first one we're going to do 2x squared minus 5 equals 3x. So we're going to solve this by factoring. I know to solve, well, one, because that's the title of our video, what we did last class, but I know to solve because there's actually an equal sign in this problem. So first thing I'm going to do, I see that it doesn't equal 0, so I'm going to do the opposite to the 3x. I'm going to subtract it to move it to the left side, and I'm kind of writing it in the middle of the 2x squared and the minus 5 so that I realize, oh, that needs to go in the middle since it has an x on it. So now I'm going to check. I have ax squared, a bx, a number at the end equaling 0. So we've put it in the form we're supposed to, even though these are subtraction signs, that's fine. Okay, so now we're going to take this trinomial, and since we're factoring, we're going to go do that in the box. Okay, so we have top left corner would be 2x squared. Bottom right corner, negative 5. Now, the guess and check method that we've been using since Unit 1, here's what we know. We know that these two boxes that are empty have to add up to be negative 3x. And we also know that we're trying to think of two numbers that multiply to make negative 5 from this corner down here, from the bottom right number. Okay, so this one's a little bit trickier because it has 2x squared, but we have an eraser if we need it. So we have to pick 1 and 5, and we're going to decide where the negative might need to go. So let's see, I'm going to try putting from 2x squared, I'm going to try saying, okay, maybe that comes from 2x times x, not just an x times x this time. And we have a 1 and a 5. Okay, so let's try it. So I'm going to take the outside and multiply. 2x times 1 fills this box. So that's a 2x. X times 5 fills this box. So that's a 5x. Can 5 and 2 make negative 3? Yes, they can if the 5 is negative. So notice it's not till we get to the box that we determine if these numbers can make a negative 3. I know over here they can't make a negative 3. But once I put them inside and multiply, I can see, okay, they make negative 3x. The outside will work if this 5 is negative. So the factors that we just got are on the outside of the box, 2x minus 5. And x plus 1. And then the extra step is that this is an equation. When it equals 0 and these two parts multiply to make 0, we're actually going to go and solve and set each one equal to 0. So either 2x minus 5 is equal to 0, or x plus 1 is equal to 0, and we solve them both. The one on the right's easier. We just subtract 1 to get negative 1 as a solution. On the left, I have to add 5, and then divide by 2 to cancel the 2 with x. And remember, we said you can leave that as a fraction, 5 halves. If you want to put 2.5 instead, that's fine. So the beginning of the practice you're going to do just asks you to factor for the first 4, and then it has you start solving after that. So let's do another one where it just asks you, well, I guess we'll do another one where we have to solve as well. So let's do 25x squared minus 81 equals 0. Okay, so on this problem, it's just a binomial. And we said, okay, what special patterns do we know? We could check for a GCF, but I don't see one here. So we said this is the difference of perfect squares. We talked about it back in Unit 1. It's coming back. We don't need a box here. We can go ahead and factor this by thinking about what multiplies together to make 25x squared. What multiplies times itself. Sorry, let me be more specific. So we said that came from 5x times 5x, while 81 comes from 9 times itself. And so then when I put this in factored form, my factors, both of them are going to start with a 5x. Both of them end with a 9. And we said to create this negative with the 81, we need opposite signs. A plus, a minus, it equals 0. So let's set each part equal to 0. And then solve. So minus 9, divide by 5, add 9, and divide by 5. Okay, so we should get the same number twice, but with opposite signs. So our actual solutions are x equals negative 9/5 and x equals 9/5. You could list them separately like we did at the one above, or you could list them together as a solution with 1x equals. Okay, y'all, so the practice you're going to do doesn't really have you use graphing as a method. I feel confident that you can use your calculator to look at the graph and see where its x-intercepts are. It will, though, review quadratic formula. So let's do a quick review of quadratic formula. I won't go ahead and sing it on video, but x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so the example we're going to do, our third and final example before you practice, is one I want you to solve with the quadratic formula. It has to have the exact same setup as factoring, where we have to have ax squared plus bx plus c, and the equation has to equal 0. So first thing I want you to do is go and say a is, in front of x squared I see nothing, so a is 1, because there is 1x squared there. Oops. B is, with the x I see a minus 4, so negative 4. And c is negative 7. So first thing we're going to do is carefully plug into the formula. X equals opposite b means it's going to take this negative 4 and make it a positive 4. And then plus or minus the square root. when we plug in a -4, we need to put it in parentheses before we square it. And then we're subtracting 4 times A, which is 1, times C, which is -7. So each letter gets replaced with a number in parentheses. And then it's all over 2A. So 2 times 1. Okay, so what we said is that we are going to take this really long expression underneath the square root and figure out what one number that is. So make sure you have your calculator. On the home screen of your calculator, you're just going to do -4. The squared button is by the 7 on the left side. Then you're going to subtract 4 times 1 times -7. Type it just like it looks on your paper, making sure to use a subtraction sign before that second 4. And I get 44. Oops. Uh-oh. No highlighter, please. Okay, so 44 here. In the denominator, 2 times 1 is 2. And we have not yet reviewed how to simplify this square root. So we said if you get it to this form, then you can stop here. And I know that's not like a warm, happy number like, oh, I know where that is. But we could type that whole expression on the calculator. So we could, let me remember it, 4 plus or minus the square root of 44 over 2. So remember, you can do alpha y equals enter. And you could type it once with a plus sign. The square root is second x squared. Right, we could go type that and see, oh, one of our solutions is 5.3. And then if I go back up, hang on, and hit enter, you can go into that problem and just change that plus to a minus. -1.3 is the other solution approximately. Okay, so you don't have to do that. That's just to kind of make sure you know that we're not just coming up with some crazy answer. We're coming up with an actual value on the x-axis about -1.3, where that graph is crossing the x-axis, even though we didn't actually graph it at all. Okay, so hopefully this helps. When you get the practice, you're going to practice by doing numbers 1 through 10. When you see 11 through 14, they have I in the problem, and that's what the notes today are going to be about. Imaginary numbers. It totally sounds made up, but it's not. So when you watch that video and go over the notes, I want you to put a star next to any of the questions that seem confusing. Now, don't star everything, but some of them where you're like, I really don't understand what's going on here, star it in your notes so that you can tell me when I'm back on Tuesday what we need to practice the most. All right, I'll have a great day and an excellent weekend, and I will see you next